Hello and welcome to this Python tutorial. Today we're going to study our second nonlinear regression model, and it's going to be the SVR. So let's start right now. Let's start by setting the right folder as working directory. So we'll go to File Explorer here, go to our machine learning AZ folder, then part 2 regression, and now we are in support vector regression SVR. So that's the right folder. Make sure that you have the position salary CSV file. And if that's the case, click on this little button here to set this folder as working directory. All right, and now let's take our regression template and let's copy everything from here to the top. Copy, and let's paste it in our SVR file. Okay, and now you're going to see how things are going to be so easy. We basically just need to create our regressor here and to change if you want some text. So for example, this here, let's replace regression by SVR. All right. And we can also change that here, fitting SVR to the data set. And here we can also specify that we are plotting the SVR results. Okay, perfect. And now we only have to do the one thing important to do here, which is the creation of our SVR regressor. So let's do this. I'm going to remove this command line and immediately create our SVR. And it's going to be really simple. We will just import the SVR class from the scikit-learn SVM library, because you know SVR is actually a support vector machine SVM, but for regression. So the class SVR that we're importing is from the SVM library. So let's do it. Let's import this class from sklearn.svm import SVR. All right, so that's the class we need to import. And now let's create an object of this class. So that's actually the SVR regressor itself that we are about to create. And as usual, we're going to call it regressor. Okay, and now since we want to make it an object of the SVR class, what we need to do is to actually call the class SVR and add some parentheses here. Let's have a look at the argument. Press Command I to inspect this class. Okay, and let's see what we have. We have many parameters. As for many machine learning models, we have the penalty parameter C that you can play with to regulate overfitting. But the most important parameter that we have here and that we need to focus on is the kernel. So the kernel is whether you want a linear SVR or a polynomial SVR or a Gaussian SVR. Well, these are the most common kernels. Then you have the sigmoid kernel. But the one we want right now is the RBF kernel. And why is that? It's because we know our problem is nonlinear, so we shouldn't use a linear kernel here, because an SVR with a linear kernel would make a linear machine learning model that would not therefore be appropriate for a nonlinear problem. And then we have the choice between poly and RBF. Both these kernels could work for our problem, but we're going to take the most common one, which is the Gaussian kernel, and therefore RBF here. So we're just going to input here kernel equals RBF, even if we don't have to. It's just to, keep track of what we're doing, because as you can see, the default kernel here is RBF, and that's why we don't really need to input that here. But it's just to know what we are doing. Okay, so actually that's all. That's all we need right now to create our SVR regressor. And now, as usual, we need to fit this regressor to our data set. That is, we need to fit it to our matrix of features X and our dependent variable Y. So to do this, we need to take our regressor object here. Here we go. And then use the fit method. And as you can see here, we need to input X and Y. So X, our matrix of features, and then Y, our dependent variable vector. Okay, so as usual, as we did before, nothing changes here. And the simple 3 lines here create your SVR regressor. So actually the code is ready now. We don't have anything to do left. We are ready to visualize all the results and get our final prediction about this employee's previous salary. So let's do this without waiting. So we're simply going to execute the sections one by one. So we're importing the libraries here. Then we are importing the data set and selecting our matrix of features X and our dependent variable Y. So here we go, done. We are all good here. And now let's create our SVR regressor by selecting this code section here and execute. All right, regressor created properly. As you can see, the default parameters are automatically selected. And by the way, we make sure we have the kernel RBF, which is important because we know our problem is nonlinear and this kernel makes our SVR machine learning model nonlinear. So great. And now let's get the ultimate prediction. So remember, this employee that is about to be hired said that its previous salary was 160K. And now let's see what SVR says. Press Command and Control plus Enter to execute. Okay, we still have the suspense. To find out about this value, we have two choices. We can either type ypred here in the console or go to Variable Explorer. And here we see that ypred is $130,000. Well, that's not good at all. What's happening here? You know, if we believed this value, the negotiation would turn really bad because we would think that the employee is bluffing. But let's not draw hasty conclusions, and let's have a look at the SVR results here. So I'm going to select this section to plot the SVR, and let's have a look. And here is our beautiful SVR model here, this blue straight horizontal line. Great. Now I'm joking. This is not the SVR model, don't worry. So what do you think happened here? Why do you think we obtained this blue horizontal straight line here? Okay, let's go back to our code. So right now you must be thinking that I gave you a bad template because I promised you that we only needed to create our data set here and then execute everything and everything should work properly. But there is some other thing that I told you 2 or 3 times that is very important. I'll give you a hint. It's in the pre-processing phase. It's about feature scaling. Okay, let me explain. So, you know, I told you that for most machine learning models, we don't need to apply feature scaling here because the libraries or the classes include feature scaling in their algorithm. You know, their algorithm written in the class. And that's why we put this section in comment. Because, for example, for linear regression, we actually didn't have to do this because it was included in the associated class. But here, we're using a less common class, which is the SVR class, and this class doesn't seem to apply feature scaling in its algorithm. And you know, this is probably due to the fact that the SVR model is a less common model, so maybe that's the reason why the class didn't include feature scaling. Well, let's actually check it out. Let's remove these comments here to actually apply feature scaling ourselves by executing this section here. But we are going to start from scratch and we're going to reset our whole code to, you know, make sure that we don't overdo anything. Okay, so restart kernel. Yes. Now restarting, connecting to a new kernel. Okay, so be careful, you know, we removed this section in comment, but as you can see, we're not creating any training set and test set here. So we need to actually replace x trained by x, and then no need to do any transformation on a test set because there is no test set here. So I'm going to remove this line as well. And you know, to make it structured, I'm going to remove that line here and put it here. Okay, and let's not forget to remove y train here and replace it by y simply. And now it's all good. We are ready to feature scale our data. But you know, it's been a while since we haven't talked about feature scaling, so let me give you a quick recap of what it's doing here. So we are creating 2 objects, SCX and SCY here, that are objects from the standard scalar class that are going to scale your matrix of features X as well as your dependent variable Y. And to scale X and Y, we're applying the fit transform method from both the SCX and the SCY object. And I guess the important thing to understand here is that you need to create 2 separate standard scalar objects because each of these 2 objects is going to be fitted to a certain matrix. So this one is going to be fitted to X and this one is going to be fitted to Y, and therefore you couldn't create one object and apply it on both X and Y. So that's why we're creating 2, and we're not only doing some fitting but also doing some transforming, that is some scaling, and that's thanks to this transform component in the fit transform method. And basically this transform tool is what is going to scale X and Y. Okay, so that was just a quick reminder and recap, and now let's actually re-execute this whole code to see if it was actually feature scaling that made this poor horizontal straight line model. Let's see. So I'm going to import the libraries first. All right, done. Then import the dataset. Done as well. And now let's eventually apply feature scaling. So I'm going to select this section and execute. And here we get a little warning. And that's because, you know, our dataset was composed before of integers, and this is just a warning to tell that our data integers was converted into float, which is totally fine because by feature scaling our data, it's transforming, of course, the data into float. If we look at X right now, we have all these float numbers here that are the result of the feature scaling. And same for Y here. Before we had the 10 levels from 1 to 10, and now we get those float numbers here from -1 to +2.7. Okay, so that's totally fine, and you know, warnings in Python happen all the time. Let's not worry about this, and let's move on to the next step. And the next step is to create our SVR regressor, and let's hope it will work fine. So I'm going to select this section, press Command and Control plus Enter to execute, and here we go. Regressor created properly with all the default parameters selected. Okay, so now we are about to find out if we get a better value than this 130k salary that we obtained when we didn't apply the feature scaling. So remember, this employee said that its previous salary was 160k. He's asking for more during the negotiation. And at the beginning of this tutorial, we obtained 130k. But before getting the prediction itself, let's perhaps visualize the SVR result first, because we will immediately see if there is an error in our regressor, because, you know, we will immediately see if we get this straight horizontal line. So let's do it. Let's actually select this section and execute to plot the SVR results. And much better now, much better than this straight horizontal line, right? Well, that is the SVR model itself. That is how it's trying to fit to the data. And we can see it's predicting each of the real observations very well now. Let's enlarge this. Okay, so just a reminder, the red points are the real observation points, that is the real salaries associated to the position levels, and all the points on this blue curve here are the prediction points. So for example, if we take this point here, that corresponds to a rather large position level, so that's about the 8th position level, so that's, if I remember correctly, a senior partner. So for this level, the real observation point corresponds to this red point here and corresponds to this real salary, and the prediction point is actually the projection of this red point on the blue curve here, and that corresponds to this predicted salary. So don't worry about the scaled value here, we will get the real predicted salary, but it's just a reminder of how to make the distinction correctly between the real observation points and the predictions. But anyway, the point here is that the SVR is now fitting much better the data set, since the blue curve is getting very close to all the real observation points. But actually there is an exception. There is this exception for this real observation point here that corresponds to the CEO that, remember, has a $1 million annual salary and has a 10 level here. And can you figure out why the SVR is doing this? Well, the reason for that, the reason for the fact that this SVR model is not fitting to this real observation point corresponding to the CEO, well, it's because the CEO is considered as an outlier here. Sorry for the CEO, but that's what's happening. And the SVR model here is having some penalty parameters selected by default in its algorithm, and therefore, since the CEO observation point is quite far from the other data points, well, the SVR model considered this observation point as an outlier and made its fit on these observation points here. So that's why we get this very well fitted model for all these observation points, but not for the CEO. But that's actually okay for us, because what we're interested in is to predict the salary of this 6.5 level that is about here, because this corresponds to the previous level of this employee we're negotiating with right now. So it's all fine, and we can actually move on to the next step, prediction step, to actually see what this SVR model is predicting for our 6.5 salary of our future potential employee. So let's do this without waiting. We would love to directly select this and execute this, but unfortunately we have to do something here. And this little something that we have to do is of course related to the fact that we applied feature scaling to our data X and Y, and therefore our SVR regressor here is fitted to X and Y that were transformed. So since 6.5 is in some way not transformed, we actually need to transform it. And that's what we're going to do right now. So basically it's very simple. What we're going to do is to apply this SCX object, that is the object used to scale the features. Well, we are going to apply this object to 6.5 so that it can be suited to the regressor. So this won't be all, but let's start by doing this. So basically we're going to go into this predict function and here apply the SC_X scalar object, and then use the transform method again. So not the fit transform, because Our object is already fitted to the matrix of features X, so that's fine. We just need the transform method. Here we go. And now we need to include this 6.5 in this transform method of the SCX scalar object. But be careful, there is a little something that we must be careful with. You know, it's always good to check the arguments of the function in case there might be a type issue. So you'll see what I mean. Let's press Command I to inspect the function. That's the transform method. And as you can see, this transform method is expecting X here, which is supposed to be an array. So this input here in the transform method must be an array. And this 6.5 value here is only a numerical value. So we will get a data type error if we leave only 6.5 here. We need to transform this 6.5 numerical value into an array. And to do this, the trick is really simple. We just need to use the numpy array, and we're going to create a simple array containing only one cell, which will contain this 6.5 numerical value. So to use this array function by numpy, we simply need to take numpy first with np, and then dot, and then array. Here we go. And now we need to open some new parentheses, and then some brackets that will contain the 6.5 numerical value here. But if we only put some single brackets, this won't be an array. This will be a vector of one element. And so to create a real array, like a matrix, we need to put another pair of brackets, like this. Here we go. So basically what this means with the two pairs of brackets here is that it's an array of only one line and one column, that is one cell, containing this 6.5 numerical value. So now let's check to see if we have the right number of parentheses. Okay, so this parenthesis corresponds to array, this parenthesis corresponds to transform, so we just need to add one more parenthesis for predict. Okay, so that's better. Now thanks to this transform method, the 6.5 numerical value is transformed in such a way that it is now fitted to the regressor. But unfortunately, that's not all. What we also need to do is to use the inverse transform to get the original scale of the salary. Because if we execute this line this way, we will get the scaled prediction of the salary. And we don't want that. We of course want the original scale of the salary. We don't want a prediction of 0.03 salary, because this is what we'll get with this line. You can try. So in order to get the original scale of the salary, we simply need to inverse the scale transformation. And to do this, it's really simple. What we simply need to do is to apply the inverse transform method. And we need to apply this inverse transform method on a particular scalar object. So according to you, is it going to be the SCX object or the SCY object? Well, you know, since the result of this bit of code here is the prediction of the salary ypred, well, this corresponds to the dependent variable, and therefore the scalar object that we need to take to inverse the transformation is of course SCY. So let's do this. We're going to use SCY just to take the object, and then that's where we apply the inverse transform method, which is here. So here we go. And again, we need to put all this part here that, you know, gets our prediction, our scaled prediction of the 6.5 level salary. We need to put all this part in parentheses because this is going to be the input of the inverse transform method of the SCY object. Okay, so now that's ready. Let's select this line and cross our fingers that we're going to get a good prediction of the salary. So let's go back to Variable Explorer to see. Let's select this line and execute. And here we go. We get a great prediction of $170,000. So that's a great prediction because first, we are quite close to the 160K salary mentioned by this potential future employee. And besides, it's on the right side of the negotiation. So the SVR is a great model. It just gave us a great prediction. And actually, if you want to have a look at the real SVR fitting curve in a high resolution, well, we can do that very quickly. We can take this last code section here to get the smoother curve. So copy this and paste it here. Okay, so now we can specify that it's the SVR results. So let's do it. Let's have a look. Execute. And here it is. So that's the real SVR fitting curve, exactly like we had earlier, but we're getting a more beautiful and smoother curve. Conclusion, the SVR is a great model. We got a good prediction of our 6.5 level salary, And in the next section, we are going to study the decision tree regression model. Let's see how they perform compared to what we've built so far. Until then, enjoy machine learning!